Thank you for organizing this seminar. It was, for me, an occasion to reflect on my own work in a critical way. I think sometimes we do need to stop for a while and see what we have done so far without the aim of defending ourselves from the waves of critics, and on the contrary, to criticize ourselves, because it's the only way to go on. So I'm going to present you my personal path, my reflections, my mistakes, and at the end, of course, I'm open to any question, remarks, or whatever. So this is the front over of more or less the beginning of my reflections and my attempts to work on spatial analysis in archaeology. This is a sort of seminal book for me. It was like I considered myself at the time a sort of apprentice, like Mickey Mouse in the very renowned cartoon. But I started doing things and using algorithms without maybe knowing much the outcome, and without reflecting much on how could we interpret what we have done. So this is a timeline. I could say 5 phases. The first one in which I developed not only by myself, also with my colleague, who now is no longer alive, unfortunately, Antonio Arnoldus, and other pupils, how to work on connectivity using the coast surfaces and the concept of attractors and detractors. And during this period, we developed some case studies. And then there is what I could label the post-dictant turn. It's a term in myself, of course. It's not a term in the scientific community. It was only my working group, and in which I reflected on how to extend, to go beyond the work on connectivity to juridical districts and symbolic landscapes. Of course, critic and self-critic is crucial, and the last phase is the current frontiers and some open questions that I will also present in the conclusion. So let's go to the first one. And the list of paths is, of course, the starting point for me and for everybody who is into for everybody who is into mobility, which is the good and the bad of this approach. I put this picture, which is quite illuminating, because it's all about pixels. I can try to forecast the potential connection between A and B, but the algorithm is very deterministic. If we have 2 neighboring cells with similar but not equal costs, the algorithm chooses the most favorable, while humans could choose another path. So in my view, this was a very, very good starting point, but it does not consider other characteristics which are typical of humans. I always give an example of a path between two villages in the Tibet mountains. They depend each other to survive. One produces food and the other produces textiles, and they need to connect. But the path they do to reach one another, each other, has nothing to do with Lisco's path. They both go to a Buddhist temple, which is quite far, to let their baggage be blessed in some way, because this is a sort of apotropaic approach to the travel. I need to have a sort of insurance on the travel. So unless you don't introduce an attractor which is symbolic, which is religious, you cannot forecast the real path. You are driven in a worse direction. Another point is the resolution of a raster on which you are working. At the time, I used to work with a raster whose cell was 10 meters. I still see people using raster cells of 30 meters. Of course, if you have a raster of 1 meter cell size, is better. But if you work with large areas, you need a very performing computer. So there are some good and bad points to evaluate. I think one good thing we have done is to introduce the concept of attractors, facilitators, and detractors and obstacles. So attractors and detractors act at a distance. That means a spring, a harbor, a market can attract people. So the path should sense in some way. The algorithm should sense, while the detractor push the traveler. Lagoons, other poorly drained soils. But, this depends on who is the traveler. Is it a monk wishing to be forgiven about his sins? Is he an entrepreneur aiming to sell his goods to a market? Is this an army moving to siege a town? The aim of movement do affect your the coast surface you are making. So, for instance, a market cannot be an attractor for a monk. Maybe it's the opposite. It's a detractor, because in the market there are sinners, while an obscure and isolated cave in the mountains where a monk is used to pray is more attractive. Facilitators and obstacles, on the contrary, act on the cell. So a ford is, of course, a facilitator. A marsh is an obstacle. Again, it depends on who's moving and the aim for which he, she is moving. And these are some first attempts in which we made coast surfaces, mixing environmental and human factors, agents. Lighter areas are better for these simulations. Darker areas are worse for these simulations. It's a matter of choice. On the left, the simulations; on the right, the roads reconstructed according to the traditional topographic method. Some similarities, but not that fitting, actually. So my first critique to myself could be this first approach possibly was in a good direction, but not much fitting. And we still use the model builder of ArcGIS. You can see it's a tremendous, complicated set of things to put. We simplified later, and I will tell you how and why. So we ended in a sort of loop, positive loop, in my view, which was the general model, so sort of deductive phase, then field verification, and then the post-diction. Post-diction started here, and it was then developed. So the problem the question we asked ourselves was, why does the real path fall here and not where we assumed to? So instead of trying to forecast the path, we ended up asking ourselves, okay, let's run several simulations until I reach one that reaches more or less what I could see on the field, in order to ask whether the agents and the weight we assigned were good or not. So we started with a historical question and we ended with a historical question. Of course, we had to confront with the problem of deterministic equations or perception. And so how much the humans were free to choose the path. We opted to move in between because at the end, after more or less nearly 20 years, I can say that I realized that there are some natural corridors, natural routes, where to move is easier, no matter climatic conditions, political changes, or who is moving. Approach, another development we did was to evaluate the match between the observed paths and the predicted paths, working with buffer zones instead of straight lines. And this is because historical maps cannot be georeferenced exactly how we really wish today with centimetric precision. And we have rasters of, say, in that case, 10-meter cell size. That means to move of 2 or 3 cells would let the path divert in another direction. So we thought that to use a buffer could in some way incorporate this uncertainty. And this was an outcome using the movement all around instead of the movement from A to B. And it was very interesting because we found potential connections between the center of power in a region and royal estates and early medieval cemeteries along these black lines that for nearly the 50% fall within the paths still recorded in the 19th century cadastre. So in this case, I was quite satisfied of the outcome because we did not know, just looking at the maps, that there could have been such opportunities. Of course, these, for instance, allowed us to explain the start number of small cemeteries that at first sight in a blank sheet could result as completely isolated and meaningless. On the contrary, they are possibly connected to the management of fiscal estates, and this has a great historical outcome. So, case studies that allow us to work on testing. I don't want to bore you with too many details. I just try to summarize that we soon realized the need to work both with environmental inputs and cultural attractors. And this is to say that we think at the end that there are human choices. Just to laugh among us, we used to say the king's road. The king is aiming to build a road, the engineer suggests a path, while the king says, no, I want to build it in another area. And the engineer replies, my lord, unfortunately, this is not suitable. There is mud, there is a marsh. Okay, I realize your remarks, but I am the king and I want to build the road over there. And so this happens, for instance, to some of Italian roads that are built and then fall down because of political input. The connection between Grosseto and Siena, for instance, where I have to travel each day along this road, is completely not natural. And it has only a political reason. They wanted to connect some villages along the road, and so they had to make tunnels and bridges in order to reach Siena. So very complicated path. Okay. So We tried several combinations. One of the good outcomes of this approach to make coarse surfaces is that we did not use simply the slopes, but we tried to include several other environmental as well as cultural factors. There is an interesting case, which is the last one, in which, despite all the attempts, I could not get an outcome of a simulation that was well fitting with observed data, until I included the harbors as attractors. In this case, it worked. So, from a post-dictive perspective, I could say that this road has an explanation only if we assume that harbors were important. And this is a good outcome, because you can see how we refined, compared to the first picture you have seen, how we refined the evaluations and how did they match better with the observed data. This led to a reflection from a historical perspective, because we have always to keep in mind that we use these tools to help us as historians. So, in this case, we realized that we have a pre-Roman road, possibly between Bronze Age and Etruscan period, which was running along the coast of a former lagoon, the early lagoon. And then Romans made a new road closer to the new shore of the lagoon to serve all the harbors that they were developing. These roads persist, not only in the Roman period, but also in the Middle Ages, and in some cases, still in the 19th century, when they built the new roads. They describe that they use large sections of the old Roman roads. So this was an exercise also to understand the movement and the long durée. Then we move to completely another set of questions. We tried to work on juridical districts. The first attempt actually was when we worked on a small town south of Padua, northeastern Italy. And we realized that this approach was fitting, because we found that the algorithm I used was the basins, to find the basins after the air work, for those who are more familiar with algorithms. And I simulated the basins among several Roman towns, and in the case of a town I wanted to study in depth, I excavated the digital terrain model with the power channels of former rivers. A very smooth, gentle excavation, just 1 meter. But it's enough that the algorithm senses that there is a sort of boundary. Anyway, the result was that the 4 milestones marking the boundary of this town actually fall on the boundary simulated by the algorithm. So it was encouraging. And we applied to the case of Lucca, in which we know more or less the district in the 11th century, and in a castle whose boundary is unknown, and we wish to forecast which could be the district. So the 2 maps are quite good description. Don't know if you can see. So this is the boundary of a town, which we can draw thanks to the sources. These are the districts, simulated districts, according to the castles and the settlements we find all around Lucca. And you see that in some cases there are quite overlapping. In the case of Salvena, on the contrary, we have present-day counties. We have, we can see not much in gray, the 19th century counties, and we try to simulate how these could work according to both cartography and basins. If we assume that these castles, these dots are castles, have all the same power. What's and cons of this simulation? Savannah was a very powerful castle. This was not a very powerful castle, so you can observe, you can reply, Carlo, you must be very careful. And you're right. My goal was not to have a map of a 13th century juridical district of a castle, which I can never have. My goal was to have a first idea to evaluate them with other tools. Is this district sustainable for the people I assume could live within the castle? Do they need to get food from other castles of the same network because they belong to a network of a seigneurial power? So new historical questions coming out this simulation. These simulations should never be regarded as true with capital letter. I always consider them hypotheses, something to useful to raise questions more than to give answers. Okay, this is a timeline. We worked in the first book I presented as a first slide also on the resource exploitation. This was another issue. Again, I was criticized. You say that this district can produce food for 3,000 people. but you're not sure that they produced food for 3,000 people. And I reply, yes, of course. This is the maximum potential production of this district if there is no fire, no war, enough rain, but not too much rain. People is gentle and working together, and everything is going well. So threshold we cannot go. The real production should be below. But at the end, we started working with numbers. Numbers that can return us an idea. This district at most could feed 1,000 people. This other could feed 3,000 people. These are numbers that can be compared. Then we go beyond. We go with the historical questions. Do we have any source? Do we have any material datum that support this production or not? So later, a few years later, we started working with positivity. And then we moved from least cost path to movement all around. In the last years, we opted to work with first surfaces, also to model juridical districts, and also recently we are working with what I call symbolic landscape, where symbolic does not mean religious, although religion is, of course, part of the symbolic realm. Symbolic can be, for instance, we made an attempt to evaluate why the early castles of the 10th century were built in bad positions. The old model made by archaeologists used to think that they were made to exploit resources, so a very economically oriented model. On the contrary, we found that it was more symbolic. They needed to build castles closer to the boundary of a juridical district, closer to the center of power, closer to areas in which there is there are more sources about the presence of fiscal estates. So the situation is more complicated. And in the last years, we tried to, as today, to have a more critical overview, to go beyond. And I just assigned a master thesis to a pupil of mine to work with artificial intelligence to figure out the settlement location choices in order to go beyond the restrictions that I have with coast surfaces, because with coast surfaces, as you can imagine, I can upload 3, 4, 10 agents. I can wait 3, 4, 5 different ways each, but it's a handmade work. Computer, of course, can simulate thousands of millions of different opportunities. I don't know which will be the outcome, of course. We are still ongoing. So, at the end, we are working with the GIS as a sort of social space laboratory where we not only analyze the movement, but also the settlement locations, the juridical districts, the resource exploitation, the symbolic dimension, and the social dynamics. Let's critique ourselves. Okay, I summarize 5 major critiques to what we have done. The first critique comes from human scientists. We cannot reduce the human complexity to simple numbers. As I mentioned before, the king's will makes the road built in a position which is awful from an environmental perspective, but he's the king. Second thing, how do you weight these parameters? It's very arbitrary. Of course, I always wrote a footnote where I declared how much did I weigh each single factor, but there's not a rule, or at least we did not use a shared view. Possibly also a sort of environmental determinism, because I found that when I evaluate, at least for the movement, only environmental agents, I have better outcomes for the long durée. And instead of using springs, rivers, slopes, we reduce to 2 major categories: the landforms. We use mainly the topographical position index and the wetness index. The wetness index is easier than working with rivers, because you have the river today, but you are not sure which was the course of the river in AD 124. So if you have the wetness area, you are more confident that this used to be an area in which, when it rains, there's much more humidity. Sometimes we have more than one solution that can explain the observed situation on the field. So we have to evaluate according to the overall complex of sources, what we have obtained with algorithms. The quality of verification, sometimes we have geophysics, sometimes we don't have. Geophysics is expensive. You can do mainly in certain conditions. Not every condition is suitable, so some troubles. But also, there are also some problems on another side, which is typical archaeologists. What do you mean by village? What do you mean by road? Is it a Roman road? 6 layers, plastered very well, like Via Appia, possibly only the few first kilometers of the Via Appia. What was about the rest? What do you mean by district? It's not that clear. We did not work on energy expenditure. There are very good examples of work with caloric cost modeling, but we did not use it. Sometimes this could be also deterministic. There are case studies, for instance, I read recently one in Sicily, in which when the peasants are asked, why do you walk along this road, which is longer lasting to reach your field instead of this one, because we used to do this. This is the answer. We do what we have to do, no matter how much time do we need. So sometimes ergonomic explanation is more into the capitalistic field than into the peasants one. Anisotropic versus isotropic cost is, again, another issue. We did not much in that direction. This is another critique I could raise to myself. Rasters are proxy data. For instance, if I wish to work on the juridical districts of medieval castles, say 12th century, and I work on the 19th century cadastre, I must be aware that there is not a transmission without any change. Castles were abandoned, districts were divided in two, and things changed. LAGAR. We are all happy when we can have submetric LiDAR, 10 centimeter cell size LiDAR. We are happy about it, but unfortunately, this is not the norm, that's not the rule when we have not much research funds. Okay, I made a new test using another algorithm instead of topographic position index, which is the geomorphon. And in this case, as you can see, to simulate the mobility, this was more performing. Is it the rule? Well, I don't know, because I should test it in all the other cases and compare with what TPI returned. There are two different ways to describe the morphometries. Similar but not equal. So this is an open question. In this case, it worked better, but possibly not in all cases. And this is the outcome. We are in Sicily, Eastern Sicily. Syracuse is on the sea. Okay, I'm almost about to end. Okay. After nearly 20 years, I could say that natural corridor identified by the GIS simulations remain substantially stable over time. And this is not only the case that we studied here in Sicily, but I worked also from, say, Germany, France, to other regions in Italy. Okay, this is the procedure. Maybe there is not much to say. I want to stress the last phase, which is S6. I consider myself an historian working on material culture, and I wish to remain an historian working on material culture, no matter if I'm using these tools or not. This was something I always try to remind myself, because when you work with GIS, sometimes the mouse can be predominant. Instead, you you should always have a question in mind. Okay. I think that at the end, I am quite satisfied of this work. Not properly because it returned perfect overlay between what I imagined, what I simulated, and what I found in fieldwork. But because this is an attempt to bridge earth sciences, history, legal history, anthropology, archaeology, and tries to make bridges among disciplines. On the right, you see what we have not done and what we still miss. Some mistakes. Sometimes we consider settlements as dots in a map with equal weight, which is historically not properly true. Sometimes possibly we stress too much the role of continuity, or at least I became more continuity, with more continuity. So pros and cons of this work. And as conclusions, I think there is a sort of originality in this predictive and postdictive approach. I think it was also a good thing to expand our perspective from gross to district and then later to symbolic landscapes. Despite we are fully aware of all the critics that we can raise. Geomorpho was a sort of good surprise. I was not very confident. Maybe because I was used to use topographic positioning. I found it easier to understand, or at least I was used to read the landscape through it. So I had to reshape my perspective. Transparency. I always push also pupils to write a footnote in which you declare your procedure, your parameters, in order to be criticized. Don't put the reader in the position of observe your map and accept or reject without having the possibility to really understand what you have done. There is something to do, of course. Energetic approach, the ontological standardization, multi-scale hierarchical weighting, so open problems. And I have finished, and so I